Hello guys, welcome to the next class. In this class, we'll discuss problems in complex number which are based upon De-Moivers theorem, nth root of unity, cube root of unity, and some series and trigonometry mixed problems also. So let us start guys straight away. First problem is x power 6 minus 2x cube minus 8. G of x is x square plus 2x plus 4. Let alpha 1, alpha 2 up to alpha 6 are roots of the equation f x equal to 0. Then the value of g alpha 1 into g alpha 2 up to g alpha 6. We can pause and give it a try. Let's start discussion now. The answer for this problem is 1600. See, if you have not solved, first of all, if you see gx, the roots of gx, x square plus 2x plus 4 equal to 0. When you find the roots, you get minus 1 plus minus root 3 iota, which you can write as 2 omega square. So gx you can factorize as x minus 2 omega, x minus 2 omega square. Now f of x is x power 6 minus 2x cube minus 8. The roots are alpha 1, alpha 2 up to alpha 6. So we can factorize like this way. Now you want g of alpha 1. So g of alpha 1 will be this. Alpha 1 minus 2 omega, alpha 1 minus 2 omega square. So what you do here, just put x as 2 omega square. When you put x as 2 omega, we get 64 minus 16 minus 8. 2 omega minus alpha 1, 2 omega minus alpha 2 up to 2 omega minus alpha 6. When you put 2 omega square, you get 64 minus 16 minus 8, 2 omega square minus alpha 1, 2 omega square minus alpha 2 up to so on. When you multiply these two, you will see this will come out to be g of alpha 1. This will become g of alpha 2 up to g of alpha 6. And this I think will be 40. So 40 square will be 1600. That's all. Next problem. 3z1 minus 2z2 minus 4 mod square is equal to 3z1 minus 1 mod square plus 2z2 plus 3 mod square. Z2 is not equal to minus 3 by 2. Cube roots of omega equal to 3z1 minus 1 by 2z2 plus 3, where w1, w2, w3 and argument of w1, w2, w3 they have arranged in increasing order. We have to find the value of w2 square by w1, w3. You can pause and give it a try. Let us start discussion now. The answer for this problem is just one. See, if ever you have z1 minus z2 mod square is equal to mod z1 square plus mod z2 square, then we can say z1, z2 are perpendicular. We have discussed in previous classes. So we can say argument of z1 by z2 will be plus or minus pi by 2. So if argument of z1 by z2 is plus minus pi by 2, that means it will be a purely imaginary number. So you can say this thing will work directly here by taking this as z1 and this as z2. So it will be z1 minus z2 equal to z1 mod square plus z2 mod square. So we get 3z1 minus 1 by 2z2 plus 3 will be a purely imaginary complex number. So this is k iota. Okay, k could be any real number except 0. So w will come out to be k iota cube root. So we can say w cube minus k iota will be equal to 0. The roots here will be w1, w2, w3. You can see product of roots here will be k iota. For this polynomial, the product of roots will be k iota. Now they ask w2 square by w1, w3. w2 square and w1, w3 we can use from here will be k iota by w2. So get w2 cube by k iota. And w2 is a root here, so w2 cube will also be k iota. So k iota by k iota you just get 1. Next one guys. It's a good problem. If z1, z2, z3 are vertices of triangle ABC with centroid at z0, z1 square plus z2 square plus z3 square is 3z0 square, then the value of this thing you have to find out. Now nothing is given about PQR, so they could be real or complex. We can't say anything. You can give it a try guys. Let us start discussion. The answer for this problem is again 1. See how. First of all, if z1 square plus z2 square plus z3 square is 3z0 square given, what we can conclude from there? You know z1 centroid will be z1 plus z2 plus z3 by 3. So when you solve this thing, you get z1 square plus z2 square plus z3 square equal to z1 z2 plus z2 z3 plus z3 z1, which will make an equilateral triangle. So you know omega is e order 2 pi by 3, omega square is e order 4 pi by 3, omega cube is 1. So we can just use rotation here. Z0 will be centroid, Z1 is here, Z2 is here, Z3 is here. So I can say Z2 minus Z0 will be Z1 minus Z0 omega because this angle is 2 pi by 3. And Z3 minus Z0, we can say Z1 minus Z0 omega square because this angle, if you rotate in this direction, will be 4 pi by 3. So put Z2 minus Z0 as omega Z1 minus Z0, Z3 minus Z0 as omega square Z1 minus Z0. When you put this thing here, you will see Z1 minus Z0 will get cancelled out from numerator and denominator. We'll be left with this thing only. P plus Q omega plus R omega square, P omega plus Q omega square plus R by P omega square plus Q plus R omega whole square. Now here you multiply divide with omega square. Here you multiply divide with omega. So if you multiply with omega square, will come out to be P omega square Q plus R omega, which will get cancelled out. If you multiply with omega here, you get P omega square plus Q plus R omega, which will again get cancelled out. So we'll be left with only 1 by omega and 1 by omega square, the one which we divide. So which will also be 1 only. I hope it is clear, guys. Next, fourth one. You see set A is the 18th root of infinity, set B is 48th root of infinity. They say when you take, like when you multiply them, Z into W, Z is an element from here, B is an element, or W is element from here. When you multiply them, will be number of distinct elements you will get. Basically, in a set, we only take distinct elements. So what is the number of distinct values you get when you multiply 18th root of infinity and 48th root of infinity? You can pause and give it a try. Let us start discussion now. See, A, like we discussed, is 18th root of infinity. So say sys 2k1 pi by 18, where k1 is 0 to 17. B is 48th root of infinity. So sys 2k2 pi by 48, where k2 is 0 to 47. When you multiply these two, you get Z into W will be sys 2 pi k1 by 18 plus k2 by 48. When you take LCM and all, you get 2 pi by 144, 8k1 plus 3k2. Let us take 8k1 plus 3k2 as k. So we get sys 2k pi by 144. You see this 2k pi by 144, this looks like 144th root of infinity. So this number will be 144th root of infinity, but we have to see what values of k will be here. And k was 8k1 plus 3k2. So we have to see what values, like see, this will be for 144th root of infinity. But if k will be from 0, 1, 2 up to 143, we'll say we'll have all the roots. So we have to see what values of k we can get from 8k1 plus 3k2. There's a small trick here. If ever you have xa plus yb, where x and y are natural number, and a and b are two co-prime numbers, like HCF of a and b is 1, then the greatest number we can't make from this combination, like by putting different values to x and y, the greatest number we can't make will be AB minus A minus B. For example, if we have 8k1 plus 3k2, 8 and 3 are two co-prime numbers. K1, K2, you can take any whole numbers here. It should be whole numbers here, not natural numbers. So see, the greatest number which you cannot make here will be 8 into 3 minus 8 minus 3, that will be 13. After 13, every number will be possible. Before 13 also some numbers will be possible, but not all. But after 13, we can safely say all the combinations will be there. Like to get 14, we can just take k1 as 1 and k2 as 2. To get 15, we just take k1 as 0 and k2 as 5. So like this, all the numbers will be able to make from 14 to 140, 14 to 143. So we'll say what is about 0 to 13? We can say 0 will be same as 144, 1 will be same as 145, and 13 will be same as 157. So you will get all the 144th roots of unity. And after that, the values will be repeating. So distinct values will be this 144 only. Next time, if you see this kind of problem, you can directly say the answer will just be LCM of them. The numbers in the starting were 18 and 48. The LCM will be 144. So next time you see this problem, you can directly say the answer will be LCM of the given numbers. Okay, guys, next. Alpha is cis pi by 2017. Solve the following. Pi r1 to 2016, alpha par r plus alpha par minus r. R1 to summation R1 to 2016, alpha par r plus alpha par minus r. Real of summation R1 to 2016, alpha par r. You can pause and give it a try. Let us start discussion now. First of all, we can say alpha par r plus 1 by alpha par r. You can see mod of alpha will be 1. So alpha we can write as 1 by alpha bar. So 1 by alpha par r will be alpha par r conjugate. And a complex number plus its conjugate will be 2 times its real part. And real part of alpha par r will just become 2 cos r pi by 2017. When they ask in the first part, they ask product here. So when you multiply all the terms, you get there are 2016 terms. So 2 will be there 2016 time, you get cos pi by 2017, 2 pi by 2017 up to 2016 pi by 2017. Direct formula we have been given to you in the class. You can just use that. It will come out to be 1 by 2000, 2 part 2016. So to cancel out, you get 1. Next, when they ask sum, so you get 2 outside cos pi by 2017, cos 2 pi by 2017 up to cos 2016 pi by 2017. In this case, you will see first and last will add up to 0 because the sum of first and last angle will be pi, and cos pi minus theta is minus cos theta. So these two get cancelled out, next two get cancelled out, so sum of all will be just 0 only. In the third part, they're asking summation R1 to 2016, real of alpha par R. So real of alpha par R will be like same thing only like the previous one. This thing only. This 2 will not be there yet cos R pi by 2017. So sum will still be 0 only. I hope it is clear, guys. Next. P of x is 1 plus x square up to x power 17 whole square minus x power 17 has 34 complex root of the form. The Euler form they have given, but the argument they have given in this form. K1, 2, 3 up to 434 and alpha A1, A2, A3 up to A34 lie between 0 and 1. So the argument will lie between 0 and 2 pi. If the same value of A1, A2, A3 up to A5 is m by n, so you have to find the sum of A1, A2, A3, A4, A5. You can pause and give it a try. Let us start discussion. The answer here is 482. So if you could not solve, see this, guys. If you see this thing, guys, we can say it will be a sum of GP. So it will be 1 minus x power 18 by 1 minus x whole square equal to x power 17. But x cannot be 1 now. You see, 1 will not be a root of the given equation, so we can directly say 1 will never be a root. So 1 minus x power 18 by 1 minus x whole square is x power 17. Now if you just cross multiply and expand, you get 1 plus x power 36 minus 2x power 18 equal to x power 17 plus x power 19 minus 2x power 18. So this 2x power 18 get cancelled out, you get 1 minus x power 17 plus x power 36 minus x power 19 equal to 0, which you can see will be factorized. You finally get 1 minus x power 17 into 1 minus x power 19 equal to 0. But remember, x cannot be 1 here. Even 1 satisfies this equation now. But 1 did not satisfy the original equation. So x cannot be equal to 1. Now if you see this thing, this will be 17th roots of infinity except 1. This will be 19th root of infinity except 1. So you get cis 2 pi by 17, 4 pi by 17 and so on. Here you get cis 2 pi by 19, 4 pi by 19 and so on. When you put them in the increasing order, you will see the smallest argument will be 2 pi by 19. Next will be 1 by 2 pi by 17. One second. Yeah, if you see this thing, they have given r k. Basically, they're comparing eta 2 pi alpha k. So those arguments we have to write as 2 pi alpha k. The smallest argument is 2 pi by 19 when you compare with 2 pi alpha 1. So alpha 1 will be 1 by 19. Because 2 pi already they have taken. So this will be smallest, give 1 by 19. This will be second. This will give 1 by 17. This will be third, will give you 2 by 19. This will be fourth, will give you 2 by 17. This next will be fifth. You get 3 by 19. So when you add them, you get 159 by 323. So sum will be 482. I hope it is clear, guys. Next, a is equal to 1 plus x cube by 3 factorial plus x power 6 by 6 factorial, x power 9 by 9 factorial, and so on. Similarly, b and c are given. They're asking the value of a cube plus b cube plus c cube minus 3abc. Okay, you can give it a try. Let's start discussion now. In this case, you can directly use this property that we discussed. A cube plus b cube plus c cube minus 3abc will be a plus b plus c, a plus b omega plus c omega square, a plus b omega square plus c omega. When you add a plus b plus c, it will become expansion of e power x. When you do a plus b omega plus c omega square, it will become expansion of e power omega x. Omega is that cube root of infinity wala, omega. And a plus b omega square plus c omega will become e power omega square x. So when you multiply them, you get e power 0. Because the powers you will add, you get 0. So answer will just be 1. I hope it is clear, guys. Next. Find the area of polygon whose vertices are roots of this equation. Z power 4 plus 4 iota z cube minus 6z square minus 4 iota z minus iota equal to 0. Let us start discussion now. The answer for this problem is 2 power 5 by 4. See what we can do here. In this equation, you will see like it looks like some expansion of something. And for that, I'll just add and subtract 1. And this 1 I'm writing here as 4c4 iota power 4. Why? Because you see first term is z power 4. Next is 4c1 z cube iota. Next is 4c2 z square iota square. Next is 4c cube z iota cube. So we add 4c4 iota power 4, which is just 1. So we subtract 1 minus iota as it is. So this becomes z plus iota power 4 equal to 1 plus iota. One thing you can say from here, if I take mod both sides, you will get z plus iota mod will be 2 power 1 by 8. And then z plus iota we can say 1 plus iota power 1 by 4. So z plus iota will be, if you use that De-Moivers theorem, will come out to be 2 power 1 by 8. Cis pi by 16 plus k pi by 2, where k is 0, 1, 2, 3. From here, you will see that Z will lie in a circle with radius 2 power 1 by 8, like this thing, and minus iota with center, like this, Z plus iota, no? So Z will lie on a circle with center as minus iota and radius as 2 power 1 by 8. And when you see all those 4 points, they'll make a square. Because the difference between the arguments, this center will be minus iota, the difference in the argument will be pi by 2. So they will make a square, and this circumradius of square is r, 2 power 1 by 8. So to find area of this square, you can just use this. You can find the area of this triangle and multiply with 4. So 4 times half into base into height, both will be radius. So answer will come out to be 2 power 5 by 4. I hope it is clear, guys. Next. Z equal to 2e power 10 pi iota by 21. W equal to e pi iota by 7 if Z minus W power 6 is r iota theta, where r is a positive real number and theta lie between minus pi to pi close. Basically, principal argument. Find the value of theta by r. Give it a try. Let us start discussion now. Just put here Z value, like Z minus W power 6. Put Z value, put W value. Take e iota pi by 7 common out. The power 6 is there, so outside you get e iota 6 pi by 7. And here you will subtract the powers. You get 2 outside as it is, e iota pi by 3 minus 1. When you solve 2 e iota pi by 3 minus 1, you get root 3 iota. Okay, and this root 3 iota, we can just write like this. Just give me a moment. Basically, root 3 iota will be minus 27. You get minus 27 e iota 6 pi by 7. But the r value has to be positive. You know, modulus has to be positive. So this minus 1 I can also write as e iota pi. The 27 e iota pi into e iota 6 pi by 7. So this thing will come out to be 27 e iota 13 pi by 7. Now 13 pi by 7 is not in the principal argument range. So how do we get in the principal argument range? You can just subtract 2 pi. So 13 pi by 7 minus 2 pi will be minus pi by 7. So principal argument will be minus pi by 7. R is 27. When you divide them, you get minus pi over 189. I hope it is clear, guys. Next. Sine pi by 3 plus 1 by 2 sine 2 pi by 3 plus 1 by 3 sine 3 pi by 3 up to infinity. So we have this series problem. We'll see how do we solve this thing with the help of complex number. You can give it a try, guys. Let us start discussion. The answer for this is pi by 3. See how. First of all, if I have this like this infinite series 1 plus z square up to infinity, we can use the sum of GP formula. 1 by 1 minus z. Integrate from 0 to z. When you do that, you get left side to be z plus z square by 2 plus z cube by 3 up to so on. On the right side, you get minus ln 1 minus z. So integrate and put limits from 0 to z. Now, to find this thing, what you will do is you'll put z equal to e iota pi by 3 and compare their imaginary part. So when you put like cis pi by 3 gets cis 2 pi by 3 by 2, cis 3 pi by 3 by 3. Imaginary part will be sine pi by 3 plus half sine 2 pi by 3 plus 1 by 3 sine 3 pi by 3 and so on. On the right side we get pi by 3 only. How? as explained here. You see this thing is minus ln 1 minus e iota pi by 3. You want the imaginary part of this thing. You get minus ln, this thing when you simplify will come out to be minus 2 iota sine pi by 6 cis pi by 6. We discussed 1 minus cis theta, so I'm using that directly here. Now, it will come out to be, upon simplification, you get e iota, e minus iota pi by 2, e iota pi by 6, which is e minus iota pi by 3, which when you take this outside, you get minus of minus iota pi by 3, so it will be iota pi by 3. So imaginary part will just be pi by 3. I hope it is clear, guys. Next. Integration of e power cos theta into sine of sine theta d theta. Now this is a good problem. Give it a try, but I think it'll be difficult for you guys, so I'll just discuss this thing. How do you use complex number to integrate this thing? Solving this, I think, without complex number may not be possible also, so we have to use complex number here. See, e power iota theta we know is cos theta plus iota sine theta. I replace theta by sine theta. So I get e iota sine theta is cos of sine theta plus iota sine of sine theta. Take conjugate both sides. You get e power minus iota sine theta is cos sine theta minus iota sine sine theta. Subtract them. It cancel out, you get 2 iotas. It will be 2 iota sine of sine theta. 1 second. So get 2 iota sine of sine theta equal to e iota sine theta minus e power minus iota sine theta. Now multiply both sides with e power cos theta. You see now the things will start getting the shape of this thing. Multiply with e power cos theta both sides, you get 2 iota e power cos theta sine of sine theta equal to, now this will become e power cis theta minus e power cis of minus theta. You will see these two are conjugate of each other. So when you subtract z minus z bar, you get 2 iota time imaginary of z. So 2 iota cancel, you get e power cos theta sine of sine theta is equal to imaginary of e power cis theta. Now e power cis theta. So e power cis theta is expansion, you get 1 plus cis theta by 1 factorial, cis 2 theta by 2 factorial, cis 3 theta by 3 factorial, and so on. So its imaginary part will be what? It will just be so this is equal to this. E power cis theta is this. Imaginary of that will just be cis theta by 1 factorial from here. Cis 2 theta by 2 factorial from here. Cis 3, sorry, sine theta by 1 factorial from here. Sine 2 theta by 2 factorial from here. Sine 3 theta by 3 factorial from here, and so on. When you integrate that, you get minus of cos theta by 1 factorial. Cos 2 theta by 2 into 2 factorial, cos 3 theta by 3 into 3 factorial, and so on, plus c. That is all. Okay, I also have explained some good problems. You can just look into them again if anything is not clear, or you can ask me in the class. Bye bye, guys.